Hello, welcome to my presentation about efficient unit testing part 3. Here we will discuss about fakes, mocks and stubs. The problem usually in unit testing is that we have a strong dependency on external objects. For example, we have here a method is valid zip file name, and we have here a logger which we create here a new instance. So everything which is created with new, it's a strong dependency. How can we solve that problem to be more unit testable and decoupled? So from this implementation, we can introduce here a new ILogger. So this is an interface, it's an abstraction. So that the is valid file name will not depend on the concrete implementation, but will depend on this abstraction. So in case of a unit test, we will inject an fake logger, and in case of production system, we will use the real logger, which itself talks to the database. What are seams? So seams are used, are places in code where you can plug in different functionalities such as fake objects by adding the fake implementation as a constructor parameter, as a public settable property, or different methods. Seams are what you get by implementing the OpenClose Principle, which from Solid, where a class functionality is open for extension, but its source code is closed for direct modification. Here we can see how the constructor injection works. So we changed our code so that the logger is injected through an interface into the constructor. And in our method, we don't create a new logger. Instead, we use the injected logger here. Fake objects. For example, this is a handwritten fake object. This basically implements the log method. Actually, it does nothing because we want to test the zip file analyzer, and we don't want to depend on the implementation of the concrete logger. Such fakes can be created also by using frameworks, for example MockQ or RhinoMock, which generate such fakes dynamically at runtime. Okay, what are stubs, mocks and fakes? We talked about fake, but let's see what stubs and mocks are. They are both placeholders for external dependency. They fake both the behavior of such dependency, and actually we're creating fakes anytime we want to have a placeholder for an external dependency so that we can test our code in isolation. A fake is a generic term that can be used to describe either stub or mock. They both look like real objects. So if a fake is a stub or a mock depends on how it's used in the current test. If it's used to check an interaction to assert against that fake, then it's a mock object. Otherwise, it's a stub. Here we can see an example of a stub, how it works. A stub is a replacement for an existing dependency. It can substitute an external dependency to either just pass by or to return some specific data for the scenario we're testing. The stub, importantly, cannot directly make a test fail. So the stub, actually we have here the logger stub, which is used by the class under test, and the assert by the unit test is done against the class under test and not against the stub. Okay. In contrast, the mock is a bit different. It's just like a stub at the beginning, but this is the difference is that the test method does not assert against the class under test. It asserts against the mock implementation. So mocks are just like stubs, but you assert against the mock objects, whereas you do not assert against a stub, right? Okay. Here is an example how we would create a mock. we can have a fake logger. This is a handwritten mock. You don't have to use an external library for this. It just has a list of messages, and anytime this fake logger is called, it adds them to this log messages list. So when will this fake become a mock? In this case, you see that the assert is performed against the fake logger here and not against the result. So in this case, the fake logger is a mock. If you would have asserted against the result here, then the fake logger would have been a stub. That's the only difference. It's not science fiction. Okay, guidelines. We should have one mock per test. If you test only one thing, that's a good thing. There should be no more than one mock object in a test. All other fake objects will act as stubs, because if having more than one object per test usually means you're testing more than one thing, and this can lead to complicated or brittle tests. In contrast, you can have multiple stubs in a test because a class may have multiple dependency. Just make sure your test remains readable. Isolation frameworks, we talked about them, is a set of programmable APIs that makes creating fake objects much easier, faster, and shorter. They are very good. When designed well, can save the developer a lot of repetitive code. Using isolation frameworks instead of writing mocks and stubs manually has several advantages and make developing more elegant and complex tests easier, faster, and less error prone. For example, MockQ and RhinoMock. Dynamic fake objects. Here we'll see how such a library works. So for example, we have such a MockQ framework where we have the mock class, and this mock can be used to customize it. For example, it has a setup method where we can customize how this should behave in case it is called, and we have also a callback, and this callback adds an item to an item list, and in the end you see here we can assert against such a log mock. So this is a mock because we assert against it and not against the result here. Mocking frameworks, we have a lot of mocking frameworks. The most used is MockQ, then RhinoMocks, and a lot more. Overspecifying the tests. So the guideline is to avoid mock objects if you can. Tests will always be more readable and maintainable when you don't assert that an object was called. These are implementation details. Yeah, there are times when you can use only mock objects, but that shouldn't happen often. Prefer testing behavior, not implementation. Your test should assume as little as possible about internal implementation details. Instead, multiple stubs can be used for external dependencies. Here we have what I want to note, that there is sometimes a mock concept confusion. The MockQ framework uses the term mock for all fakes, for both mocks and stubs. You have to know how many mocks and stubs there are in a test, because more than a single mock in a test is usually a problem. When it doesn't distinguish between the two, the framework will tell you that something is a mock when in fact it's used as a stub. It takes you longer to understand whether this is a real problem or not, so the test readability is hurt. So here's an example. We have two mocks, one for view, one to logger, and here we verify that this log was called in a specific way. So to distinguish this, we have to know which of these two mocks, either the view or the logger, is a stub or a mock. So here clearly the log is a mock because we assert against it, and the view is a stub because it's just a placeholder. Better, as we said, we can name it differently. So here we can have a stub view, and here we have a mock logger, because this is actually the mock where we assert against it. Good. Notes about fakes. It's important to lean toward return value or state-based testing as opposed to interaction testing whenever you can. Mocks should be used only where there's no other way to test implementation, because they eventually lead to tests that are harder to maintain if you're not careful. The art lies in knowing when to use dynamic versus handwritten fakes. So it's that depends on your taste. When such an isolation framework starts to look ugly, maybe it's better to simplify things and use a handwritten mock. So this was the final part of the fakes, mocks, and stubs video. And in the next part, we will see qualities of test code.